Essentially, all chemical reactions and changes in physical state involve either a release of heat or an absorption of heat. So in this chapter, we're going to be discussing those changes. In this chapter, we'll be studying a special field of chemistry called thermochemistry. Thermochemistry is concerned with heat changes that occur during chemical reactions. So when we're looking at these changes in energy, energy is the capacity for doing work or supplying heat. And if that is within a chemical substance, we call that chemical potential energy. So we'll be talking a lot about heat in this chapter. Heat is defined by the letter Q, or abbreviated by the letter Q in some of the equations that we'll be learning. And heat is energy that transfers from one object to another due to a temperature difference between them. And it's important to note that only changes in heat can be detected. Our substances, our reactants start with a certain heat content and then they end up with a different heat content. So we can only look at changes. We can't study heat directly at any given point in time. So if I have a glass here and I fill it with regular tap water at room temperature, it'll probably be about 20 degrees Celsius. And if I put ice cubes in that water, of course solid ice is at 0 degrees Celsius. So we know that the water is going to get colder. But what's happening here? Does the ice cubes cool down the water, or does the water heat up the ice cubes? Well, the water actually heats up the ice cubes. This is kind of contrary to what some people may think. Heat can only move from a hotter substance to a colder substance. So in heating up the ice cubes, we're actually taking heat away from the warmer water, and that's why the water gets colder. So in studying heat changes, think of defining these in two parts. You have the system, that's the part of the universe in which you focus your attention on, and then you have the surrounding, that's everything else in the universe. So in this little scenario here, I have a beaker filled with a chemical, and I am going to put in a lump of metal in. Now a chemical reaction is happening that's giving off a lot of heat. So in this case, the system, what we're focusing is the reaction happening in the beaker. The surroundings is everything outside of the beaker. So in this case, heat is flowing from the system to the surroundings. If you held this in your hand would get warmer. Because your hand would be the surroundings, the system would be the beaker in your hand. Now, if you had like an instant ice pack and your hand felt colder, it would be the opposite. Heat would be flowing from the surroundings, your hand, into the system, the ice pack. So there's something called the law of conservation of energy, and very important in this chapter on thermochemistry, and it states that in any chemical or physical process, energy is neither created nor destroyed. Just like mass is neither created or destroyed, same goes for energy. All the energy can be accounted for, it just transfers to different forms, or it can be stored. So when you have heat flowing into a system from its surroundings, that's defined as positive heat or positive energy. So if we calculate Q, which I'll show you how to do later, it would have a positive value. These types of reactions where heat flows into a system from its surroundings have a special name that you need to know. They're called endothermic reactions. And in every endothermic reaction, the system gains heat or gets warmer as the surroundings cool down. So this is what an endothermic reaction would look like on a reaction coordinate. So on my x-axis, I have the transition from the reactants to the products. And on the y-axis, I have energy. So endothermic reactions always have this kind of representation. So they start with the reactants. They have a certain energy content. In this case, it is low on the y-axis. It's lower down. And then they absorb energy as they transition to the products. And the products end up with a higher energy content. So endothermic reactions always go uphill in graphs like this. If you have heat flowing out of a system from its surroundings, that's defined as negative because Q will have a negative value in the calculations we'll be learning later. And these types of reactions are called exothermic reactions. Exothermic reactions are one in which the system loses heat or gets colder as the surroundings heat up. So here's what an exothermic reaction looks like in a graph. So the reactants have a certain energy content, and through the course of the reaction, as they transition to products, they lose energy to the surroundings, and the products end up with a lower energy content. So exothermic reactions always go downhill in the graphs like this. So in summary here, there's always a change in energy in any physical or chemical process. Energy can't be created or destroyed according to the law of conservation of energy. And you should be able to describe the flow of energy or heat between the system and the surroundings for any chemical or physical process like this. Remember, an endothermic reaction is one which absorbs energy. The little graph will be going uphill as the products have higher energy than the reactants. And an exothermic reaction always releases energy. The reactants have higher energy than the products, and they release it to the surroundings as they transition to lower energy products. These are just two vocab words that you need to memorize, and you'll see them a lot in this chapter and potentially other chapters as well.